This is a video because this year I've decided to get into an Arduino Mega relay type setup on my Christmas lights. It's a little late this year to be starting this. What I've got out in the yard right now is one of those $140 type charge pre-set up music boxes like Mr. Christmas music, and it's a little bit different. It was an old GE one that I've had for 6 or 7 years, and it's got 4 zones on a wireless, and so you get 4 zones out in the yard. So they'll blink and flash to those different zones, and they come with 12 or 20 pre-made songs, and you turn them on at night, and everything kind of links up, and they'll flash, and it's kind of cool. I've in the recent couple of years I've been putting some LEDs out there, and I've got some chase light LEDs and some flashing LEDs that'll flash to music with a music controller, just listening to music. And I've done that the last couple of years now, and I've got a video outlining those type of lights in my on my channel. But this year I'm a very get into a very basic setup on the Arduino. In the past, I've looked at Light-O-Rama, which is the prevailing if you once you get beyond the Mr. Christmases and 6 zones or 4 zones with the preset, and you just plug them in with AC plugs. Plug in your lights into zones, and it pre-plays these things, and it all routes back to a little central thing. And those things cost, I don't know, $100 to $200. Um, is the next step up is the Light-O-Rama type setups, but you get a little bit of sticker shock with the Light-O-Ramas. It's kind of if you buy their pre-made kit, the starter kit or whatever you want to call it. So it has the software, and it has the control board and the relays, and I think it's 16 channels. Starts at about $700, and then it's like $300 if you want to add another 16 channels, and it keeps on escalating like that. So you'll be, for a 32 channel, you'll be coughing out $1,000. And then I guess maybe for a little bit more, you can buy some of these pre-made ones or put them in an SD card. But those have to line up. You have to line up your display with what those pre-mades are. The reason for doing this type of stuff is to kind of get the custom ones and get the hot super flashing and all that kind of stuff. The stuff you see at the really nice YouTube and other light displays. So yeah, this is my first shot at an Arduino setup, which is kind of a discount Light-O-Rama. You're going to have some of the same problems that you'll have with a Light-O-Rama, and you're going to have to spend a busload of time. I anticipate spending a busload of time, which is why I don't think that I'll get done with this year. But I wanted to go through. I did follow a quick YouTube Simon Champion. You can look that up. He's got a 6-part series over. He's a British guy that just kind of went with the basic. Again, I'm going to follow kind of his setup, but some of the problems I had, and I've kind of built a different box. My box is a different build method. I've seen a lot of other boxes built, and it looks, it's pretty complicated. So what I'm going to do here, and of course there was a couple problems watching his video too, just that I experienced coming out of the gate, that I had to spend a couple hours researching. He also references the do-it-yourself Christmas lights.com website with the forum, and people are helpful and all that kind of stuff. I did have to quickly check into that because I didn't quite get the setup right a couple times, and other ones I figured out. So I'll go through this, and this is kind of my journey. Again, I'm only for this video. I'm going to show a quick eight relay setup. I've got another 16. I'm sorry, I got another 8. I did order a mechanical relay, but I'm using the SSD solid state relays. So I'm going to try to get. I'll probably have 16 in this week, so I'll probably do my setup for 16. Simon Champion's map that he was kind enough to give out. You can download the Arduino map, or sketch they call it. Has 32 channels, and of course I think you can get up to close to 50 channels, or at least the 48. So 8 times 6. So that on one Arduino board. So that's kind of eventually what I'll spend a little bit more money, and I'll talk about that side. But yeah, it'll be far less than the $1,000 for 32 channels. To do it this way, you just have to do a little work yourself, and it's not prepackaged for you. So what you see on the screen here on the bottom here is the Arduino controller card. I use the Mega 2560, I believe is the number. It's one of the more common ones in play now. I got all these components on Amazon. They range anywhere from $20 to $40. Some of the $20 ones are knockoffs, I guess, or whatnot. I decided to go with the $40 version just because it's another 20 bucks, and I'll live with that. Hopefully it's being an authentic one. You'll see some ribbon cables in there. These are just torn apart from a ribbon cable. You can get these 40 piece if you look up 40 pin. These are male to male for this particular setup, but they also sell female to male and female to female. As a matter of fact, there's a $9 pack that'll give you three 40 pieces of all the 3 different varieties. So I've got that on order because of what I figured out is, hey, it'd be nice to have some male to female, but I knew for this application I was going to have male to male, so I ordered those quickly. I'm not using all 40. I've got them set off to the side, but I'm using 8 of them here. That's what's bridging the 2 cards that you see there. The top card is the Sainsmart, SIAN Smart. They're pretty popular again on Amazon. I went with the solid state relays 8-piece. I originally was thinking, I saw a 16 relay, and they got these big old honking relays on them. They're mechanical, and you also see an 8-piece that's mechanical. I think the 8-piece was $15, the 16 was $32, and if you want these solid states, it's an 8-piece for $32. And the 8-piece is good enough. You can keep on buying multiples of those. You can see they're not, really get a discount. They're not really scalable that way. The difference between these solid states, which is these thin little black relays in there, and I have a picture later on of the mechanical ones, is that the mechanical ones make a whopping amount of noise. You do hear the things clicking and clacking. So if you watch some of these other videos, people have got it set up with this Arduino setup, and it's going click 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 click, and then depending on the frequency, it gets really really loud. So they say, hey, you need an enclosure. You don't see these with the solid state. They're pretty quiet, so you can actually use them indoors, or you can just have this thing situated indoors where you don't have to put it per se in an enclosure. And so I've got the 8-piece just set up here because that's all I've got in house now. Like I said, I got another board coming, but it's $33, $32 a board. Let's just say it's 35. And so it's got it's got the power going into it. It's got the 8 pins, and it's got the 2 pole relays coming out. So all you're doing is breaking and opening and closing a circuit, and so 8 times. These things are on and off. I don't know if you can fade them. I know there's a lot of effects in the Vixen software, which I'll talk about eventually. We'll end up using the Vixen software. But I've just got them going on and off for this basic first year routine. The only other thing that I got in the picture here is you'll need to buy either acquire one from a phone charger, or you'll need to buy a 5-volt charger that plugs into the wall. That's what I got there, and you can see I broke out the wires to plus and minus because they go into they're sort of the red wires. The black, it's a whole black unit that's swirling around. It comes on the right side of the picture there, and that's where you get the plus and the minus. And you can sort of take another jumper and go from there to another solid state relay board, and I think you can jump 4 Scott. Simon Champion, I would keep calling him Scott. There's another guy, Scott, out there that attempted to do some of this stuff too. You can watch both those videos, but you can go at least 4 boards with the, as long as your 5-volt adapter there has at least 500 milliamps, and most of them nowadays, just a regular old cell phone, have over 1 amp. I think I got a 2 amp there, which is 2,000 milliamps. No problem there. That's those 3 components. Those are 4 components there between the ribbon cables, the 2 cards, and the adapter. The last thing you see sticking in there is the USB plug. It's that one I had just lying around here, but you're going to need to buy one of those to connect to a computer. It's an old printer type cable setup. I forget the micro number, A or B or whatever you call that. But hopefully you got one hanging around. If not, you have to pick one of those up. And again, Amazon is one of the cheaper things we got. And just for reference, I did buy a $15 8 relay mechanical clicker clacker. What you'll notice at the top half of that, it's not male pins going into it. You'll have to procure females. Either an old IDE cable or just buy for $3 or $4, buy a 40 pin, and you just strip off the 8 pins you need. So if you're going to use that setup, you will need female coming onto these boards because the pin header is sticking up at the top there. At the bottom, you'll also notice they have 3 attachments per leg. The middle is a common, and then the left is normally closed, and the top is normally open. You'll use 2 of those 3s, probably the normally closed, so that when the relay closes, that you will close the circuit and light up that channel. But other than that, it's behaves basically the same. It just makes a lot of clackety noise. So for my setup, there's a couple, there's ways you can drive anything through those relays. Those relays will go up to European, which is 240 volt, 50 hertz. But for my example, I'm going to use American, 120, 110, whatever you call it, with the 60 hertz AC power. But you could put 12 volt if you had LED lights or something like that. They're running off 12 volts or any voltage you have, and they'll go through the relay. All you're doing is really breaking the positive line, and then the relays clamp down and turn on, and then power gets distributed out to the receptacles, right? Or they could be manually wired into Christmas light strings or the LED type lights. So, but I'm going to use the 120, and I am going to use after my setup, on the output of my setup is going to be 8 plugs per board. So I get these 2 plugs here, which are pretty standard. I think they're like $1. You can be either cheaper than $1 or up to $1 for these tamper-resistant ones. And you'll need, of course, they have 2 plugs on them. So for an 8 relay board, you'd need 4 plugs. So I just wanted to show you that real quick. So on these plugs, when you're dealing, first of all, my first disclaimer, when you're dealing with AC power, you're talking about real house power here. 12 volt low power lines doing LEDs, not a problem. But here you're actually dealing with real house power. So just like you wouldn't take 2 knives and stick them into a socket, got to know what you're doing. You take your time to do it. It's not difficult, but if you complete a circuit, you're going to get a good amount of power, up to the 15 amp circuit breaker or whatever you got in your house. So as I'm looking at a receptacle here, I've got the middle. They're always 3-prong with these grounds and stuff like that, and a ground hole is the middle one. And I'm putting them down bottom just for reference here. It's usually how we set them up in America. And on the left-hand side, you'll see that there's a wider slot than the right-hand side for any particular receptacle. So you have a big receptacle and a thinner rod. The thinner rod is your hot. If you just keep that in mind while you do all your work, you definitely, as you wire these up, 4 of them, you don't want to switch them back and forth because you're going to connect a circuit, and then you're just going to be running power, and the wires are going to get steaming hot pretty quick, and either I guess they'll melt and break and have their own fuse eventually, or you'll pop a breaker back at the thing immediately. So just as you look at this on the right-hand side. There also happen to be gold screws as opposed to silver screws, if you can see that detail. Is that that's the hot side, and the left side, or the silver side with the fat plug, is the neutral side. And I'm not going to use ground in this case. We don't use a lot of ground when we're out there doing Christmas lights. Usually they just put 2-pole in America. So yeah, just using the 2. But I just want to give you a heads up. So on the neutral side, which I'm not showing in this slide, it's the opposite side. This is the gold slide, which is the hot side. The hot side, we're going to break the 2 tabs, so the two plugs, receptacles, operate on the differently on two different plugs. Right in the middle there, you'll see a little bus bar This is how they come stock. So you just wire up one of those two screws, and both plugs have the same power. But we're going to break that off on the hot side so that each one works independently. Like I said, the neutral side will keep it together. Here's a picture on this one here where I have the bottom one has it broken and the top one is still sitting there. So you just take a a needle nose plier or whatever, and you just wiggle it back and forth. It'll eventually break, and now the top plug can be wired different than the bottom plug. So effectively, I get two different plugs off this one receptacle, which is what I want. So I can control each receptacle, power to each receptacle separately. There's a lot of different enclosures you can put out there. I see people have a lot of metal boxes that they eventually, four receptacles, but two of these little double receptacles go into a square box, and they'll line up, four for a total of 16 inside an enclosure, and they're all metal, and there's another enclosure. In this case, I went with the, if you go to Home Depot, you pick up one of these plastic cases that hold four of them. They hold all different numbers up to four, 1, 2, 3, or 4. You also, in general, it's a little more expensive for the old work versus new work. New work has the nails to nail into a stud, and it's got these flanges sticking out there. The old work is a little cleaner, so that blue thing back there costs about $6. But it holds four of these receptacles into them. I just got them laid in here, showing you how they're going to look. And it's not waterproof, but it's kind of nice because you don't have a metal case in case you got some stray ground or a power wire touching, the side of a thing. It's just a little bit safer, but it's a few more dollars. A new work one is $4, and those metal ones, I think, are $1 a piece. So you'd need two of them here. So it's $2 versus $4 versus $6. But I just always like the plastic ones, old work. So that's what I'm going to use for this, even though it's a little more expensive, a little nicer. The relay boards have, they're through-hole components. That means there's a lead, the end of a thing going through that's soldered. So they stick out further than the bottom of the board. So you really just can't lie the board flat on a piece of metal or anything else like that, or inside an enclosure. Because you would get metal to metal, joining circuits together, potentially. So you either have to raise it off that metal with some stands, like from a computer or something like that. In my case, I just got a cardboard box, and I didn't even bother to try to do the holes that are existing. You can see I put two holes out there, put a tie wrap, strung it between an area where, it would fit. So I got one down bottom, one up top, just through, and then on the back side of it, just complete the zip tie, and just a nice easy setup for doing that. I did the same thing here over on the master. So yeah, if I screw up my setup, it's not like it's a big metal piece, and I put all this stuff with screws and spacers and insulation and all that kind of stuff. I just get another piece of cardboard or poke another couple holes in the cardboard. And that's how I've mounted it. I might rearrange this Mega because the way the pins, you can see I'm using like pins 2 through 9 is where you see connections there. I know there's a board as you go around the perimeter outside, but basically most of your exterior connections going to everything you see on the bottom side here is analog in, and the power on the left. You don't really need power to this board when you plug in a USB that's plugged into a computer. The USB, that's a 5-volt in, and that'll power the Arduino itself. But as you expand, there's a double row on the right there where a lot of those those start to make up the 50 pins that eventually. So you take another 8 and send it to another 8 relays, and send another 8 to another 8, and you do 4 of those, it's 32. 6 of them, 48. So that's how you continue to expand your system, just by plugging in. And these are just male plugs that just hand slide down there. They don't lock in or anything, just like a header, just like you take to anything you're plugging in on PC World. On the other side, on the relay side, there's a screw. And again, it's nice to have that male. And you just undo the screw, stick it in, and then tighten it up, and it's good and tight. So that's all you need to do for the hookup between the two boards and the power. So again, this is what the USB side that goes into the Arduino looks like. Down below it, there's a black, so you could do a separate power supply. But really, if you just hook up the USB, but you're going to need one of these old, I call them printer, because a lot of the old printers came with this USB connection. And the other side of the USB is just what goes into your computer, a nice flat rectangular one. But you're going to need to pick up a cable that has one of these on one end so you can plug into the Arduino. So again, this is just an overview of what I got mounted to a piece of cardboard. That black adapter will have to get plugged into a wall socket that's got power. And the other half, like I said, I stripped it and just put the black and the white. There's sort of next to those two places that I'm plugging in on the relay card. There's a diagram next to it. There's, it starts at 1 on the left and goes through 8, and then there's a ground one is the 9th one. I don't know if you need the ground one. I don't think you do. It's the oddball brown wire that goes over to the left, and I've taken it off and it doesn't seem to do anything. So I don't know if you need that or not. Of course, the two prong header that's got the red and the black wires, those are let's see, it's ground, and then power is on the right hand side as we're looking at it here. And again, when you get the next relay card, you would just daisy chain out of there and hook that power up to the next power and the next power, so they're all on the same circuit. They do draw some milliamps, but again, if you go at least 500 or more in your 5-volt power supply plug-in, then 500 milliamps, I hope I said, then you'll be good to go to power 4 of them. Safer to go with more, I guess. For this project, I'm using these Enclosure, IN-SURE, just Home Depot. What these are is I'm using the 4-port version. I think these are $2 or $3, $220 or something like that for a 10-pack. Just a nice way to quickly connect wires. You see, I'm going to be doing a lot of bus joining type, and the nice thing about these are encapsulated, so if they float around inside the box or wherever. They do sell bus bars. I didn't have one. I do have a couple here, but you know how they are. You gotta, they'll be like metal pieces, and so anytime you got a big metal neutral hanging around that's floating around, you'll have to secure it down or do what it is. But for the price of these, not too bad. When I get going, I'll be using, it's a 4-port, so one of the ports will link to another one of these. So one of the ports is lost, just wiring between and just keeping the chain going. But at least the middle two will attach to the relays, and so I'll need at least 4 of these, right? Because the middle two will go into the 8 relays, and the externals will join each other, and eventually I'll join to the hot side of the plug that's going to go into the wall, because I'm trying to join all the hots before I get to my setup. It's not important that I run separate hots into the setup, because the relays are going to be open, and it's when the relay closes that hot will go out of the setup. So I'll need to do some joining on the inside on the hots, and I'm going to use this nice little Ensure port to do it. Of course, you could use just the old round ones that you twist and do 2 at a time, and keep on splicing. You can do it any way you want. You can solder them together. You can do whatever, but this is just a quick way to do it. So you have a choice to make in wire. Here I've got I had some wire hanging around, and it happens to be white 16 gauge stranded wire. You'll have to make a choice between you're not going to use a lot of this wire, so it doesn't really matter a whole lot. But if it's solid wire, which is not stranded, then it will go into the relays. Everything goes in a little bit easier, and it definitely goes into the receptacles. That's built. You strip the 1/2 inch and you insert it in the straight way, and it you don't even have to do the screw bit. But the downside to that is they don't bend very well. and you'll see that I'll want to do some bending when I get into the box. It's not that they don't bend, they do bend, but this is what I had. So at the end of the stranding is a little bit more difficult, takes a little more time. But you can use either one. You'll need some at least 16 gauge wire. When you think about the heavy duty plugs that go out 3-prong on your 50-foot extensions, those are 16 gauge is the expensive one, or 14 gauge or whatever. But 16 is plenty for what we're running here for the little bit of stretch. And those wires I think are like a 25-foot there is $5. You pick them up in the electrical area in Home Depot or Lowe's. They stand alone, just sort of like that shot you saw. But over here is a picture where I've wired up using the multi-port connectors. So in my case, I stayed consistent. On the right, there's the 8 outputs, and there's 2 prongs to each one of those output. On the right-hand side, I've tied them all together. So that they're all tied on the same circuit. So that's essentially, I'm going to hook that up eventually to the power hot coming in. And then on the output, I've got longer cords. I think I cut them about 1 foot. You want to go at least 1 foot. And of course, you could run these 100 feet out to the yard if you wanted to, or whatever you had. But in this case, I'm going to go with just 1 foot for demonstration purposes, and I'll use extension cords after I plug where I plug. So it's just a matter of trading off this wire length for extension cord wire length, because normally you got this set up, your garage or in your house, not in the middle of the yard, because you're going to have a computer driving it, and so you'll need to get out to your yard or your house eaves or whatever. So how you do it is up to you. I wouldn't use probably white wire. If I was going to run this out, I'd use black or brown or green. These all come in colors, and of course you'd be getting hundreds and hundreds of feet, so you might want to step to the 14 or the 16. 16 should be pretty good, but you'll be running these. So I got 8 of those coming out the left. Each one of those is hooked on the left of the 2 on the relays, and they're all stringing together. So I'll need 8 of those. They're going to go into my box, and those are going to power the 8 receptacles. And so here's just a quick shot where I brought those. I used a piece of painter's tape just to number them 1 through 8, because I've got all the same color wire, so that when I get in there, I'll be able to hook them up in an order that makes sense. Otherwise, your receptacles are all over the space. It's nice to be organized here and do it in an organized manner. I've also brought in one of a brown wire. All I've done is cut an extension cord, 16 gauge extension cord. Normally you'd use with your Christmas lights, and I've split it. And again, the one that goes into the box is, this case, it's the neutral, because I'm going to hook those all up in a common across all the receptacles also. Again, so you take a little X-Acto knife or any type of scissors and you give it a cut. I've splayed them apart, and the hot side, which is the short, non-wide, narrow plug side, and it's also typically the side that doesn't have ribs. Typically the side that has a fatter, wider is the neutral, and typically it's got ribs on the outside of that particular guy to identify even when you splay it apart. But make sure you trace them back to the plug. And I put the neutral coming into the box too. So that's what this picture is trying to show. Because I'm using stranded wire, it's just a lot easier, rather than trying to curl stranded wire and compress it, to just buy a 75 pack of these 14-16 gauge crimp on. You don't want the ones with the circles, because those you got to take the screw out, and that's a pain in the butt. These ones just slide in and put the for the bolts on the side of the receptacles. So buy a pack of these. They're not too expensive, $2 or $3. So I've made some some short wires on the neutral side, and I've attached the splays to them there, the splice splayed on, crimped on splices. And so you hook up what in the front view here, I've got terminal 1 and 2, and then I'm just going to number top left as 1, and then two's below it, and then the next row over, the next column or whatever you want to call it, the next set of receptacles, it's 3 and 4, 5 and 6, and 7 and 8. And so this is the silver side, or the neutral side, that is facing the camera here. And so I've come in, and the first brown wire, you can see, goes to the first receptacle here, and those are still joined by the bus. I didn't break the bus tab on those. So I can take the other half of it and wire it over to the next receptacle, and then again take the other one and wire it over the next receptacle and alternate, left and right, and then take the other one and go to the last receptacle. The last receptacle back there only has one connection, but now I've got the neutral. It's all the common neutral, and it's all tied back to the plug that's going to go into the wall. So then the same type of thing, crimp on an attachment, and here I've got number 1 going to the top. Make sure that your 3-prong is face up, so then just go in order, so that way you can either write it on the box later, but it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Hopefully those come back to your mappings to be plugs 1, 2, 3, 4, 5, 6, 7, 8, or a multiple of that. So whatever you plug in there, you know what the controller number is without having to. Otherwise, once you get 16 or 32 or 48 lines out there, and the Christmas trees, everything's going to be out of order if you don't do your math here. So, and just keep yourself organized. So you want to attach this, and you want to attach, 3 through 8 in the same manner to the appropriate receptacles. These again are the bus broken hot sides, so they're independently controlled. 2 wires per receptacle. So after you get it all wired up, again, go ahead and take those outside screws, tighten them down in the existing thing, and then it kind of looks nice and clean there. I'm not going to put a cover or anything on it because, again, it's not waterproof, and this would normally be in a wall somewhere. But I'm going to eventually, if I have to put this outside, I'll have a box I put it in, just an enclosure, big plastic tub or whatever that just keeps the rain out of falling in. The rain, if it does go in there, doesn't puddle up, because you did have to break out one of the entrance points down there, and I've got all the wires coming in that entrance point. So here's what it looks. It's kind of a nice looking, and again, the upper left is 1, bottom right is 8, and it just staggers that way. So the last thing to do is to take the hot side of the extension cord that you cut, the plug that's going to go into the wall to power this all up, and you'll want to attach it to the hot in. So I've got there's a couple extra spare spaces here because I happen to do 3 on the first one because you got 3, and then the fourth one was a jumper, and as it went along the line here, so it ends up, instead of having 2 wires on this last one over here, it doesn't really matter. This is the 4 times 4 out points that I'm doing, and I can plug it into either one of those, and so that's how I'm going to get hot power coming from the wall into the relay board. All right, at this point, since you're dealing with AC current, it's a good idea to get a multimeter out there. In this case, I took one of them and stuck it through the hot leg. So that's my red probe. And then I've gone all the way down to the end, which I remember I plugged all the hots into the right side of the relay card, the inputs. So here I'm doing a circuit connection. It should beep for resistance. You're on resistance here. Not powered in, right? So all you're doing is checking that you're getting power, and specifically you can touch the other. I'm just touching the top of the screw on the relay card. If you touch the other screw, you shouldn't get any power because the relays are open right now. And you can do all 8 connections on the relay card to make sure that you get power on the right hand side and you're not getting power on the other. I'll save you a headache, and it'll also make sure that you've got them isolated properly. Then after you do that checking, you can take the neutral side, which is the other plug, and same type of thing, except for you're not going to be going to the relay card. You'll be going to the neutral silver screws in the box. I'm not going to show it here, but you can just touch all 8 silver screws. Make sure you're getting, or at least 4 of them, because they're bust. And make sure you're getting neutral to all those receptacles. Of course, it just won't work if you're not getting the power. And the next thing you do is take one of your leads and put them in the left of the 2 relays. And what I like to do then, after I put it in the left, so if what I'm showing you where the black one goes in is number 8, according to my view here. But if I touch one side to that, and I touch all the positive hot or gold sides, gold screwed sides in the box, I should only hear get resistance connectivity on number 8. So I want to make sure I got number 8 and I'm isolated from 7, 6, 5, 4, 3, 2, 1. So you want to do that check real quick and then go to relay number 7, same type of thing, touch it on the relay card, the output, and make sure it's only going to 7 and you only isolated to 7. That's the best way to make sure that you're not getting, didn't cross a wire and are not somehow feeding a loop. It could be A, dangerous, or B, your thing isn't going to light up very well. So you want to do this basic check. It's good electronics 101. It's worth the time to make sure that everything is connected, and then probably every season do the same type of thing. Just make sure that everything's still connected correctly. So I had another number of problems with the Simon Champion setup. His sketch was fine. He's got a link to download a sketch on his YouTube site there. But I experienced two problems. First of all, my sketch wouldn't it would compile, but it wouldn't upload to the Arduino. And the reason for that is there's a setting, and we're talking about you have to go to the Arduino.cc. It's not .com, but you go to the Arduino site and you download the Arduino software version 1.0.6 or whatever I got. But its default is like the Arduino Uno. So if you've got a different version, you'll get what it comes across, and it says, sync error, right? It's a big long error, and I looked that up online, and it basically said, hey, you didn't go in and choose your controller. Once I went back and I choose the Arduino Mega 2560, then the sync problem went away, and it was able to talk to the board and able to upload the sketch to the board. That's the first thing you have to do is go and download the Arduino software, and then you have to get a sketch in there, which is what I opened from. We also had to put the sketch inside the folder. I think it's a common 0 is his folder. So when you download his zip, they're all in the same directory, but you really want to, it'll kind of create the directory for you, but you need to drop the .h and .c files down into that lower directory that's got the name of the common, so that whatever the one that you're pulling up, the INO file, and there's a bunch of H and C files. The INO file, that's got to be in a directory name the same as the thing. So that wasn't explained in this video, but that was a stopping point. And so once I figured that out, and I dropped the H files in there, and I went over to the common one, right, the leftmost one or whatever you call it. That's what you open when you do the Arduino software, anyways. And you just compile it and then upload it, and it worked fine. And he's got it set up for 32 LEDs, pin 1 through 32. And then, but they do have a mixture. If you ever get in the details, you can look at his one of the things got to set up so it doesn't, pin 2 on the Arduino is pin 1 in the software, and it kind of goes in a funky little pattern like that. So if you ever get stuck, refer back to that particular file in the Arduino software, and you'll see just it calls out, it's like a definition file. And when you upload or apply power to the Arduino, so basically that's when you cook the USB into your computer, is when the Arduino gets power, is that there's that green power light comes on, and then it's a little hard to see in this picture, but then it will cycle through each relay for like half a second. So you'll see the lights, the LEDs light up, and if you got something plugged in, you'll see that light up too. So there's a couple different, if you don't see those lights, or if you don't have anything plugged in and you see the lights, you're set up right, the lights on the relay board. But you can kind of see what pattern they go, and if something's screwed up, you can, I guess, redo the wires. Quickly on the Arduino, you can just pull them out and swap them, or you can go back to the map if it's a big problem, or if so one of them's not lighting, then that's probably you'll have to go back to the map to figure that out. The other problem I had with the Vixen software, and I'm using Vixen 3 something, I know he's using 3 something, I got a newer version, it looks a lot different, it looks slightly different, but the menu's the menu. The controller setup, again, I use like Comfort 4 and just followed his stuff because it was an open COM port, and it all seemed to work pretty well, especially once the Mega is connected in there and it's in your LPT in the device manager. It's all pretty good to watch his video real quick. The only other thing is that he calls it a squiggly apostrophe. I didn't quite get that one right away, but basically it's really we're talking about the header when he says to do the header text string. It's the squiggly, which is of course next to the 1 key with the shift held down. So that's the squiggly, and then the second character is actually the exclamation point, which is the 1 key itself with the shift held down. I know he said squiggly apostrophe, and I loaded that in. It took me, took a while to go figure it out, but I did go to the do it yourself, and it's squiggly exclamation point is your string header. Other than that, it's pretty easy to use the Vixen. Of course, you want to load the Vixen software from the Vixen site, which is out there, and it's free. So you're not spending any, other than I hooked it up to a netbook, and I know there's one menu that doesn't, you can't see the whole, you can't move it enough on a netbook, which is a squish screen. But really, you didn't need that. You just, you do your controller, you do your elements, and you do your mapping or patching with the graphical patching pattern there, and it all works out pretty good. Again, I just use the set levels, the faders and stuff. I haven't really played around with, and these relays aren't set up to fade, but it's pretty quickly you can do that. I also had a problem with the waveforms initially in the Vixen software. When you import music, it's supposed to show a waveform up top, and I had brought in, I got a free MID file off the internet, and I tried to rename it MIDI. It took it. It wouldn't take an MID, but if you renamed it MIDI, it took it, or if you rename it WAV, WAV, it took it, and it played it. But the whole waveform was black, so you couldn't really see the waveform, and that was a little discouraging because the waveform is slightly helpful to see the big frequencies change and where you're getting a lot of intensity, because that's how you're going to want to set up your lights. What I did notice, I thought I was freaking out, and I was looking up a lot. I spent a lot of time trying to error check that on the boards. But at the end of the day, if I just dumped that file and I downloaded MP3s, when they came in, they read it, and I got a nice waveform. So if you're not getting a waveform, it's your file, not so much the software. There is no setting to get you that on Vixen 3. So when you put it all together here, I've got a quick intro. I didn't really bust out the Susie Snowflake song, but you can see that I have added the elements. I got 8 channels. I'm watching the LEDs flicker here, according to the Vixen running the sequence. And this is exactly the same things as with the LEDs, except for I got a bunch of strands plugged in, and you can see how they flicker. I can get them down to 1/10 of a second. Is pretty good fast, slow type switching. So your mind's your imagination after that. Obviously I'm going to add, I've got another solid state relay board on Q. The solid state relays, like I said, were 35. The wiring, everything going along. I think it's going to be in the neighborhood of $50 to add another 8 channels once you've got the original Arduino and the original 8 solid state relays, because it's 35 plus 6 for the box and another 4 for the receptacles, and then you got some wire and some stuff in there, so it's just going to add up to another $5 worth of stuff on average. So somewhere around $50 to add another 8, but that's a lot better than $300, which is what Lightorama costs. Again, maybe I'll figure out how to get some more sophisticated patterns out there and stuff, but I'm just in trial mode right now. So thank you for watching. If you have any questions, I guess you can shoot them to me, but I'm not going to be the expert. Just good luck. Go to the do it yourself, or visit some of the other videos where people have done stuff. But this is a quick, simple way to make your own light show. And certainly it's in the neighborhood of that. For 16 channels, it'll be in the neighborhood of that 150, 100 to $150 that you'll pay for that 6 to 4 channel pre-made light show. Other than you're going to spend quite a bit of time. Even though the Vixen software was pretty quick so far to make a pattern, you always want to tweak with these things, but it's fully customizable. I think what's going to cost you the most is getting that extra either wire out to the yard. That's a cost I haven't quite accounted for yet. I'm just going to be plugging extension cords into these and getting them out there, or I'm either going to buy a big spool of wire and then somehow figure out how to do more receptacles or something out there, if that's cheaper. Whatever's the cheapest way to get them out there. But you're going to be running a lot of wires in this system as opposed to daisy chaining 4 or 6 big zones, because every element of every item can have this. I might play around with the LED, like a 4-color LED, because I would be able to at least control the red, green, blues, and then make any color I wanted it, even though it's the same tree or the same whatever star or whatever I've got. I would be able to change at least the basic 3 colors and then any mixture thereof, and I'm not sure if it'll do the frequency fading to get all those weird colors, but at least you get, like, I don't know, whatever, 16 colors or something like that. So I'll think about that too, but remember that would be probably on 12 volt. 12 volt in, so I'll just have to swap around. I'll have to get another one of these relay cards or do what you can do. The other thing I recommend is that, get yourself a those anything that reads amps on the input, like a kilowatt or something like that. And so if you're gonna plug these boxes into a common item, usually because you're doing such small, you're not doing 15 chains of LEDs on the same zone. But you do want to do an additive and make sure that you're not, if you need more than one 15 amp circuit breaker or whatever, you can't run anything in the house. Just keep an eye on that. You can plug that in at the head, or you could plug it in every receptacle and see what kind of amperage you're pulling when it's on. But your tendency is to start to drive more lights with these light shows this way. You start to say, hey, I'd like to, even though they're a small amount per channel, they are all feeding off the same AC plug at the end of the day. So yeah, make sure that just keep an eye and see what kind of usage you're using, and make sure you can still use the microwave or whatever in between, or whatever's on your circuit, or get a dedicated circuit, or split them up as necessary, so that you don't want to be blowing circuit breakers all day long. I don't know how long the USB cords will reach, but the other thing is, yeah, you want to protect your computer or leave it indoors. Vixen will actually, once you make a sequence in Vixen, which is like a song, you can actually put a show together, which is a bunch of sequences. But that's for another video, another time. Thank you for watching.